Okay, guys, 9.7, properties of matrices. Now, we've used matrices back in the beginning of chapter 9 to help us solve systems of equations, okay? These are the same types, but we're going to work with matrices just more in general. This will be very useful if you're going into a field, math, physics, engineering, something like that, usually one of those STEM fields. Matrices are used in a lot. They're actually very useful with very large calculations. That's how, if you have a system that's, 1,000 by 1,000, you use matrices, when you're working with the computer to actually help you solve them. So it is a good idea to have a good understanding of matrices. So we're just going to work with different matrix operations, adding, subtracting, multiplying, things like that. Okay, so what we have to start with is we have to talk about the dimension of a matrix. Okay, we need to know the dimensions of a matrix. Okay, and the way we talk about the dimensions, the size of these things, is it's just the row by the column. Okay, so remember, rows are horizontal, columns are vertical. So to start us right off, an example, find the dimension of each matrix, identify any square, column, or row matrices. Okay, and I'll show you an example of that. So if we look at this first one, what I want you to notice is there's 1, 2, 3 rows. Okay, so we define it as row by column. So the size of this is 3 by, I have 1, 2, 3 columns. So this is a 3 by 3 matrix. And it's also a square matrix because it did want us to mention that. And, well, why is it a square matrix? Well, because it's a square, 3 by 3. Okay, so that's that first one here. Now, sometimes you'll get matrices that look like this. So what am I noticing? How many rows are there? Well, I'm noticing that there's just one row. So the dimensions are 1 by, I have 1, 2, 3, 4 columns. So it's a 1 by 4 matrix. Okay. Now, when one of the dimensions is 1, you always either have a column or a row matrix, okay? Since this is just us all in a row, this is a row matrix as well. It can be classified as. And row matrices and column matrices, they have a lot of use when you get to linear algebra. So if you're studying math or engineering, physics, there's a lot more to them and you can really go in depth. But just so we know the terminology for now. If I look at this one, I have 1, 2 rows by 1 column. So this is a 2 by 1 matrix. And of course, we can also call it a column matrix. Okay, so you do want to be familiar with this sort of terminology here. And then finally, D right here, I have 1, 2 rows. So it's a 2 by 1, 2, 3 columns. It's a 2 by 3 matrix. It's not a square matrix. It's not a row matrix. It's not a column matrix, right? You only have a row or a column matrix when one of the dimensions is 1, okay? So this is simply just a 2 by 3 matrix, okay? So not too bad. This can be really useful when you're trying to type a matrix into your calculator like we did on some of the previous examples because you actually know what dimension you want, right? So let's get to the first operation, addition and subtraction of matrices, okay? To add or subtract 2 matrices of the same dimension, add the corresponding elements. And I should add in there, add or subtract, right? So this is one of those green boxes you may have seen in the book. I just turned it into, instead of just addition and subtraction. And what's important here is that only matrices of the same dimension can be added or subtracted, okay? Reason being is in a lot of applications, you have a lot of these rows and columns, they stand for different things in actual, could be engineering applications, and you can only add things that have the same types of things to add, you could think about it as, okay? So if we go down here, add or subtract the following matrices if possible. Now, if I look at this, it's got 2 rows, 2 columns. This is a 2 by 2 matrix. Same idea here. Okay, this is also 2 by 2, so I know I can add these. The way to add them is to add the corresponding elements. This is an element of the matrix, 7 right here, or 9. So this is literally the first element of our resulting matrix is 7 plus 0, just adding these. The second element is 9 plus 2. Okay. This element here would be 4 plus negative 3. And right here I have a 1 plus 12. Okay, so just the corresponding elements. So it doesn't change the size of the matrix. So I have 7, 11. This is going to be 1, and this is going to be 13. That's us adding those two matrices together. Let's go over here. B. This is a 3 by 2, and this is a 3 by 2. So I'm able to do the subtraction. So how does this work? Well, subtract the corresponding elements. 1 minus 0 is 1. Negative 3 minus negative 2 is really negative 3 plus 2, or negative 1. 2 minus 3 is negative 1. 0 minus negative 5, that's 0 plus 5, is 5. Negative 5 minus 0 is negative 5. And 4 minus 1 is 3. So there we go. And once again, 3 by 2. Finally, C, this is a 2 by 3, 2 rows by 3 columns. And this is a 3 by 2, 3 rows by 2 columns. These don't match, so we cannot add these, not possible. Okay. And you can actually put these in your calculator and you'll see that you'd get an error in that case. We will see how to do that when we're talking about multiplying matrices. The last thing I want to talk about in this video is the scalar multiplication of a matrix. Okay. So what do I mean by a scalar? Well, you can think of the word as scale, like when you scale something. Okay. So a scalar really, I mean, it's usually what we work with in math. We just don't usually call it that. It's just a real number. Okay. And we call it that when we're working with matrices, so we know the difference between, say, an element in a matrix and just a regular number, a scalar. Fact, when you're multiplying a matrix by a scalar, the scalar scales each element of the matrix by that scalar. Okay. I think it's easiest just to show you some examples. So look what I have here. Here I have a scalar, just a number, and I'm multiplying it with this matrix right here. And it literally just scales every element in the matrix. 4 and 0. So notice I started with a 3 by 2 and I ended with a 3 by 2. So once again, it keeps the same dimensions. We can do scalars that are fractions too. Let's see, this would be 1/4, 2 over 4, or 1/2, 3 over 4, 1, 5 over 4, 6 over 4, or 3/2. Same dimensions. So that's just multiplying a matrix by a scalar. Okay? In the next video, we'll talk about multiplying matrices together.